Hi, welcome to the Explainer series for Quant. Here we'll be using very simple concepts and apply it to CAT level problems and solve them as easily as possible. Hi, this is a session on indices. We look at the basic properties of indices and solve a few questions which came up in the recent CAT, XAT and IIFT examinations. The last question is actually a very interesting twist on indices. I would suggest please look at the PDF. The link is available in the description of this video. Pause this video, try to solve these questions on your own, and then proceed with the rest of this session. Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. So we'll start with the basic properties of indices. Indices are something which you should definitely not miss. If something you have to study for numbers in algebra, something you have to master, indices, logarithms, etc. and surds are something which you should definitely master. These are things which you should study. As we discussed earlier, they are very common in these examinations and they come up very, very frequently. You can solve them in about 1.5 to 2 minutes times. Some of the questions might be tricky, but you can do it if you know just these basic concepts, right? These are things which you will find in most of your CAT preparation books. If you don't have them, just search online on Wikipedia. You will get these basic properties of indices pretty easily. We'll use this as a reference as and when it's required, and let's try to solve them. So how easy are questions on indices? This easy. Okay, this question can be solved in under a minute. This came up in CAT 2006, considered to be a pretty difficult paper, right? Let's see what this says. If x is equal to minus half, which of the following has the smallest value, right? Now, x is a negative number. So the first thing that you should check is if you have a negative number and a positive number, right? We know always that a negative number is always going to be lesser than a positive number, right? So if you have a negative number and versus a positive number, you can eliminate the positive number straight away, right? So let's try this. A is 1 by 2 to the power minus half, right? Whatever be the power, because it's the base is 2, right? Whatever power you raise it to, it is going to be a positive number. So this is going to be positive, right? 1 by minus half. So it will be minus 2, which is negative, right? So obviously A is going to be lesser than B. Let's look at C. X square again becomes positive. Inverse of a positive number will still be positive. Out. Minus x again will be positive, right? Square root of that will be positive. Option B will be a correct choice. In about 45 seconds to a minute, you can solve this question. So as I said, don't miss a question on indices. These are the easiest wins that you can get. Okay, not every time you'll get this lucky. Okay, this one is from CAT 2017, slot 2. Not too difficult, right? Let's see what this says. If 9 to the power x minus half minus 2 to the power 2x minus 2 is equal to 4 to the power x minus 3 to the power 2x minus 3, then what is the value of x? And you have the options given to you. One way you can do is directly substitute the options and try to fit this, right? The easiest option looks like to substitute is 3 by 2, because then the powers of you'll have at least 3 by 2 minus 1, you'll get a natural number, this you'll get a natural number, this you'll get a natural number, this you'll get a natural number or a fraction, and you will be able to at least try to figure that out. Right? So that is one way to do it. Other way is to resolve it slowly. Let's try to resolve it. We'll combine powers of 3 and powers of 2 in one side. Okay, if you take the powers of 3, this will be 3 to the power 9 is 3 square. So applying this rule, right, you'll get 3 to the power 2x minus 1, and then this will come up over here, plus 3 to the power 2x minus 3 equals. On the right hand side, you will get this 4 is 2 to the power 2, so 2 to the power 2x, right? This will become plus 2 to the power 2x minus 2. Now let's try to resolve this. This will get 3 to the power 2x divided by 3 plus 3 to the power 2x divided by, this is 3 to the power 3 is 27, should be equal to 2 to the power 2x plus 2 to the power 2x divided by 4. Right, I'm doing it slowly so that it's you can take as much time to solve this. Okay, let's try to resolve this even more. If I take 3 to the power 2x common, this will be upon 27. 9 plus 1 is 10. Should be equal to 2 to the power 2x. There should be 1 plus 4 will be 5 by 4. Okay, this goes out, this becomes 2. Again, we'll club the powers of 2 on one side, 3 on one side. So you'll get 3 to the power 2x divided by 27 equals 2 to the power 2x divided by 8. Now, at any of these stages, you can obviously use the options and reduce it. I'm just trying to do it as simple as possible. Right, now again, we'll resolve it to powers of 3. 3 to the power 2x minus 3 equals 2 to the power 2x minus 3. Now, once you get this, it should not be very difficult to resolve this. Okay, the easiest way to do it is bases are different. Bases are different. Now, the only way these two values are different, these two values are same, is if the index becomes 0. Only when the index becomes 0, you will get this to be equal, unless both the indices were 1 itself, right? In which case unless both the bases were 1, in which case the indexes don't matter. But because the bases are different, right, the only way to match these two will be when 2x minus 3 will be equal to 0 or x will be equal to 3 by 2, which is what we guessed initially as a initial guess. Again, as I said, at any stage, you can probably substitute the values once you've resolved this slightly and put the options to solve. Less than 2 minutes to solve this question. Okay, let's try the next one. Okay, this came up in IIFT 2015. Again, in an IIFT sort of a test, if you get this question, this is a gold mine, right? Not very difficult to solve. It says, what will be the value of this expression? Your options are 4, 8, 4 to the power p, 8 to the power p. So everything is in the powers of 2. It can be either 2 to the power some power of p or just 2 to the power some natural number. Okay, so let's do everything in powers of 2. Remember, the final value is raised to this power 1 by p. So we'll look at this later. Okay, let's resolve the rest of the part. So we'll take it in powers of 2. Okay, 2 to the power. Let's calculate the power. Okay, this will be 2p plus 2 by 4 will be half. Okay, root of 2 will be half. Square root of 2 to the power p, again applying this rule, this rule, this rule combined in some form of the other. Okay, so 2 to the power p will be p by 2. Now, this is addition. A to the power n into a to the power n will be a to the power m plus n. Now, for division, it will be subtraction. So let's do this. This will be minus 1 and this will be minus half. Minus of minus half will be plus half. So p by 2 plus p by 2. Right, whole divided by p. This will be the power of 2. P will be 2 will be raised to this power. Okay, half plus half is 1. 1 minus 1 is 0. So this is out. So what power of 2p plus p by 2 plus p by 2? P by 2 plus p by 2 is p. P plus 2p will be 3p. 3p divided by p will be equal to 3. So your final answer is 2 to the power 3, which is 8. Job done. The next one is from CAT 2019 slot 1, not too difficult. You have m and n are integers such that this is the relation. What is the value of m? Now, both m and n are integers. So, if say 2 to the power x equals 3 to the power y, then either both of them are equal to 0 or the only other way out is if one of them is an irrational number. Right? You'll otherwise not get the same powers because this is a prime number, this is a prime number, you will not get that. So the easiest way out is, because we need two equations to solve two unknowns, we will first equate the powers of 2 and then equate the powers of 3. Now let's first equate the powers of 2. On the left hand side, the powers of 2 are 19 by 2. We are using these relations, right? 19 by 2 plus 4 square is 2 to the power 4 and 8n. 8n is 2 to the power 3n. This value should be equal to, on the right hand side, 16 to the power m. So 4m plus 64. 64 is 2 to the power 6. 6 by 4 is 3 by 2. Right? If you rewrite this, you will get 3n equals 4m. 3 is 16 by 2, that's minus 8. This will give you 8. 8 plus 4 is 12. Right? 3n is equal to 4m minus 12. Okay, if we equate the powers of 3, right? If we equate the powers of 3, this will be 4 plus 2m. 9 to the power m will be 3 to the power 2m. Should be equal to 3 to the power n. So n. Right? Substitute this n here. We'll get the value of m. So you'll get, multiply this by 3. You'll get 12 plus 6m equals 4m minus 12. If you rewrite this, you'll get 2m equals minus 24. M should be equal to minus 12. Option C will be our correct choice. Okay. The last one basically was from XAT 2018. It's a very interesting question on indices. Let's see what this says. David has an interesting habit of spending money. This year he spends exactly rupees X on the Xth day of the month. For example, he spends 5 rupees on 5th of any month. Okay. So whether it's January 5th or February 5th or March 5th or December 5th, he'll spend 5 rupees on that day. On a few days this year, David noticed that his cumulative spending during the last 4 consecutive days can be expressed as 2 to the power n, where n is a natural number. What can be the possible values of n? Right. So it has to be powers of 2. So n is a natural number, so it can be 2, 4, 8, 16, 32, 64, 128, so on. So the sum of the amount spent on last 4 days, right? This adds up to one of these values. It can be 2, 4, 8, 16, and so on. Now, given that it's a natural number, it cannot be 2, 4, or 8. Even if you take 1, 2, 3, 4, it's at least 10, right? And even if you take the highest values, say 31, 30, 29, and 28, the addition will come to, this is 60 plus 50, 90, 90 plus 28 is 118, cannot be 118. So it can be one of these 3 values. That is one way to do it. Okay, let's check what is going to happen. If you take 1, 2, 3, and 4, right, this adds up to 10. If you remove 1 and take 2, 3, 4, 5, right, you're removing 1, adding 5. So this will add by 4. So it will be 14. Similarly, if you take 3, 4, 5, 6, you will be removing 2, adding 6. So add another 4. So 18 and so on. Now, but none of these values will result in a power of 2, because this is 10, this is 14, this is 18. None of them is a direct power of 2, right? So this scenario cannot hold good. But if you look at the options, you have 5, 6, 7, 8. And there was one more option because it's that examination. I removed that option, but that you will not be able, that was not a none of these option. Right. So how do we go about doing this? What are we missing here? Are we missing something? Right. So till now we have considered everything in 1 month. What happens if you have something like this? On 31st is one of the days. Then it spills over to the next month, right? So you have 29 and 28. These are the scenarios which are also possible, right? These are also scenarios where you can have 4 consecutive days adding up to something like a 16, 32, 34, right? So let's see those scenarios, right? I have written this down to save some time. One is when the month ends in 31, one is when the month ends in 30, then on 29 and 28, and all the scenarios which are there. Now, this is not too difficult to calculate. If you calculate one, you'll be able to calculate the other 2 very easily. I'll show you how to do it. right? If you add these three, this will be 31, 30, 29. That's 3 into 30. That's 90 plus 1, 91. Now, obviously, 91 does not satisfy. Now, in the next addition, you're removing a 29 and adding a 2. So we'll be subtracting 27 from this. Right, this will give me 64. Right, which is what I wanted. Right, 64 is what I wanted. So this is one such scenario. This is one such scenario. Okay, let's try this. Okay, again, you'll be subtracting 27 from this. You'll be getting 37. So this is out. For the next set, we will have, this will be multiplied by 3. 29 into 3 will be 87 plus 1, 88. This is out. Now, what will be the change here? You're removing a 28 and adding a 2. So losing 28, adding 2. So you'll be losing 26. 88 minus 26 is 62. Again, you'll be losing, you are removing a 29, adding a 3. Again, losing 26. 62 minus 26 will be 36. This is also out. This is also out. Okay, let's add this one. This will be 84 plus 1, 85. What will be the difference here? You're taking out a 27, adding a 2. So subtracting 25. This will be 60. This will be 35. Out, out, out. And in this case, 27 into 3 is 81 plus 1, 82. What is the change? You're removing a 26, adding a 2. So subtracting 24. This will be 58. This will be 34. Right, again out. So only one such scenario holds, right? Only one such scenario, which was a month which ends in 31. So suppose, for example, on February 3rd, you come and check. On February 3rd, you come and check. You'll have 30, 31, 1 and 2. If you add this, you will get 64, which is the power of 2. When will this happen? Every time a month ends in 31, it will happen. So on February, the next month will happen. So February 3rd will be the case. Then Jan ends in 31 days. So after Jan will be Feb. So on Feb 3rd, it will happen. March has 31 days, right? So April 3rd, you will have this. May has 31 days. So in June, on June 3rd, you will find this. July has 31 days. So August 3rd, you will find this. So July, you will have 31 days. Again, August has 31 days. So on September 3rd, you will find this. October has 31 days. So on November 3rd, you'll find this. Now December has 31 days. Right? But the next January is next year. This is only for this year. This is valid only for this year. Right? This entire question is valid only for this year. So the next January, on January 1st and 2nd, you might spend different amounts. Right? So you cannot say this. Right? So on 6 days in this particular year, you'll be able to find this. It's a beautiful question over here. Uses concepts of numbers, calendars, as well as basic powers of indices as well to solve this. The other questions on indices, you basically understand the simple relations between base and the index. You can solve them over here. In all these questions can roughly take you to solve. I mean, the XAT question will probably take you about 3.5 minutes, but that's usually the case with most XAT questions anyways. I mean, they are lengthy, they are much more conceptual than the CAT questions. CAT questions and the IIFT questions will take you 2 minutes time, especially if they are in indexes sort of a relation. Don't miss out on indices. They are an awesome arsenal. They can basically help you quickly go through questions in a CAT examinations. If you're stuck with a geometry or any of the other permutation combination problems, go ahead and solve an indices, Surds, logarithm sort of problem. In about 1.5 minutes time, you'll either be able to solve it or you'll have to skip to the next question. That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.